welcome. Today, we will discuss another episode of the Electrical Axis video series. Before we continue, subscribe and hit the notification bell to get updates to our latest topics. The problem that we are going to answer this time belongs to the fundamental concept of electric circuit analysis. As you can see from the figure, there are three resistors that are connected in series and supplied by a 50 volts DC source. Now, the value of the first resistance is 10 ohms. On the other hand, the value of the second and third resistance is unknown, with symbols Rx and Ry respectively. The resistance Rx has a voltage Vx, while the resistance Ry has voltage Vy. Now the problem requires that, if the value of Vx is 10 volts, while the value of Vy is 20 volts, calculate for the value of Rx and Ry. To answer this problem, we need to apply first the concept of Kirchhoff's voltage law, which states that the sum of all voltages around a loop is equal to 0. Also, we need to apply the concept of series circuit, pertaining to the value of electric current, which states that the value of current that passes to all resistors is the same. Therefore, we can say that the current that passes to 10 ohms resistance is equal to Irx, and also equal to Iry. And now, we will assume a direction of flow of the current I to be clockwise. If we can get a negative value of current later on, it means that the actual flow of current is the opposite, which is counterclockwise. Now, by applying KVL around the mesh, we can form an equation of 10I plus Vx plus Vy minus 50 volts is equal to 0. Substituting the given values of Vx and Vy, we can calculate the value of I to be 2 amperes. At his point, we can finally get the values of Rx and Ry using Ohm's law formula. Ohm's law states that I is equal to the voltage divided by the resistance. By simple manipulation of that formula, we can get R is equal to the value of voltage divided by the value of current. Substituting the values Vx and current, we can get the value of Rx to be 5 ohms. Similarly, by applying the same process, we can also get the value of Ry to be 10 ohms. Finally, to check whether the obtained values are correct, we can substitute the answers that we get to any equations that we made while we are writing our solution. In this case, we will use the KVL equation that we write a while ago. Substituting the values of Rx, which is 5, and Ry, which is 10 ohms, we can get an equivalent resistance of 25 ohms. Multiplying it to the value of the current, which is 2 amperes, the answer is 50 volts, which conforms this KVL equation. Therefore, we can conclude that our answer for the values of Rx and Ry is correct. We hope that you enjoy and learn from this video. Before you leave, we are again requesting you to subscribe to this YouTube channel and hit the notification bell to get updates on our latest topics. See you next time.